The question is if the first and the nth term of GP are A and B. So basically, let's talk about little about the GP. So what is a GP? It is a sequence in which the ratio of the two consecutive terms, they are same. Like we say 2, 4, 8, 16. So if we will divide the particular two terms, if I will divide these two terms, so 4 over 2 is 2. If I will divide these two terms, then 8 over 4 is also 2. So every time when you are dividing the two consecutive terms means one after the another. So you are getting the same answer. Okay, you are getting the same ratio. So that is a GP. Okay. Now, if you will decide, if you will see that they are saying that the first term is A. First term is A. So wait a minute. First term that is equals to A, and they are saying nth term of GP is B. Nth term is B. So whenever we are talking about the nth term of GP, so there is a particular formula for the nth term, which is An is equals to A times R raised to the power n minus 1. So A is the first term, which already given in the question, A times R, that is a common ratio, and it's the number of terms. So this is the particular formula for nth term. But they are saying that nth term is B, so An is equals to B is equals to A times R raised to the power n minus 1. Okay, so this is the first thing that we figured it out from the question. Next thing what they are saying, that P is the product of the n terms. So this is capital P, so take it as capital P only. Okay, now we have to prove that P square is equals to AB together raised to the power n. This we have to prove. Okay, so let's do that. So what is a general GP? General GP is AR square, AR cube, and so on till AR raised to the power n minus 1. So last term are having the power 1 less than n if we are talking about n terms. So if they are talking about the product means the multiply, which is P, that is equals to A times AR. We just have to multiply all the terms together and dot 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 multiply AR raised to the power n minus 1. Okay. Now if you will see, every term has A. Every term has A. So how many terms are there? N terms. So it will be A raised to the power n, right? A raised to the power n. These are not in addition. So you will say that, ma'am, these are not in addition. So you will say, ma'am, it is NA. No, they are in multiply, or whenever they are when some numbers, the same number as in multiply, like A. So there are n terms. So it will be A raised to the power n because every term has same base and the power is 1, 1, 1. So how many ones are there? N ones, so n time 1, so A, n. Then we will talk about R. This R, then we have R square, then multiply R cube, then multiply dot 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 R raised to the power n minus 1. Now if you will see, product is equals to A raised to the power n times R. Again, the base are same. So we apply the law of exponent again. So when the base are same, the power will get added. So it will be 1 plus 2 plus 3 plus 4 plus dot 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 n minus 1. Now you know that this is a AP. If you will see that this is an AP, right? A1 plus 2 plus 3 plus. So what is the general formula for finding out the sum of AP? So there are basically n minus 1 terms. N minus 1 terms. So it will be S of n minus 1 is equals to, what is the general formula for Sn of AP? That Sn is equals to n over 2 to A plus n minus 1 times D. This is the general formula. Because we are having the n minus 1 term, so n is become n minus 1, n minus over 2. 2 times A is what? The first term is 1, n minus 1 time. This is n is n minus 1, so don't, in the formula, we n as n minus 1 and there is a minus 1 in the formula, and D is what? The difference between the two consecutive term. That is 2 minus 1 is 1, 3 minus 2 is 1, so D is 1. Okay, so when we will sort it out, so it will be 2 plus n minus 2. So minus 2 minus 2 cancels out, plus minus 2 plus 2 cancels out, and we are left with n inside the bracket. So we are left with n minus 1 over 2 times n. So this is the sum. So we put it here. So P is equals to A raised to the power n times R raised to the power n minus 1 over 2 times n, right? Now, if you will see, the power n is common to you. Power n is common to you. So I am taking power n common. Okay. Now in the question, what we have to prove? P square. So let's do one thing. We just make the square of P both sides. So squaring both sides. So P square is equals to a times r raised to the power n minus 1 over 2, it's 2n, because this is also a power and there is another, I am doing the square. So it will be n times 2, that is 2n. Now I'm taking this 2 inside the bracket. Okay, or let's do one thing. Just a second. So wait a minute. This will be, yes. So this is that. Okay, now if you will see, if you will do the square, so p square is equals to, we have a, right? We take the power inside. So 2 times r raised to the power n minus 1 by 2 times 2. Okay, so this I am taking. Now if you will see that this 2 cancel out with this 2. So what I left with, wait a minute, just let me remove the page. Let me remove the thing that is not required now. So p square is equals to, what I left with, a square times r raised to the power n minus 1. We are left with this thing. Okay, we are left with this thing. So if you will see, p square is equals to a times, I'm just taking it as a times a, r raised to the power n minus 1. So p square is equals to r raised to the power, what is this? R is a times r raised to the power n minus 1 is b. So I'm putting it as b, and n we have outside also. Don't forget this thing. And we have outside also. So it will be this one. Okay. So I put this equation here at this place because I just break a square as a times a, and this equation I put as b. So ab raised to the power n. And don't forget the power here. We have just taken 2 inside and n is outside. So I forgot to write it. So that is that. Okay. So yes, thank you everyone. Thank you so much.